All right, let's dive right into this explainer and demystify the core instruments of automotive repair. Today, we're focusing entirely on tightening and loosening tools. You know, an automotive toolbox isn't just a heavy box of metal. It's a highly specialized, incredibly logical arsenal where every single angle, finish, and shape exist for a very specific reason. Even if you absolutely know your way around a garage, staring at a massive spread of tools can feel kind of chaotic. But we're going to break down exactly what you're looking at. By the end of this explainer, you won't just see a pile of metal, you'll see a collection of brilliant, purpose-built engineering solutions. So here is our roadmap for today. We're going to cover welcome to the shop, classifying your automotive tools, mastering the open-end wrench, box ends, 6 versus 12, the anatomy of sockets, and finally, rules of the wrench. Let's get to it. Section 1. Welcome to the shop, setting our objectives. Before we even think about grabbing a tool, we really need to know how to identify, maintain, and use them safely. The golden rule here, using the wrong tool for the job isn't just wildly inefficient, it's a massive safety hazard, and honestly a guaranteed recipe for damaging expensive automotive parts. Section 2. Classifying your automotive tools, breaking down the arsenal. Mechanics classify hand tools into 5 distinct buckets: gripping, cutting, driving, measuring, and tightening. Now, a busy shop relies on all of them, for sure. But for this deep dive, we're zooming in entirely on that very first category, tightening and loosening tools. These are the true bread and butter of automotive work. And just to complete the taxonomy of the shop, we also have our power tools. These are broken down into electric, pneumatic, which just means air-powered, and hydraulic. Actually, keep those pneumatic air tools in the back of your mind, because they're going to directly influence the design of some heavy-duty sockets we'll look at a bit later on. Section 3. Mastering the open-end wrench, angles and applications. You've probably held a classic open-end wrench, 100 times? But have you ever really looked closely at the head? The open-end wrench is totally defined by its geometry. Specifically, a jaw opening situated at a 15 to 80 degree angle relative to the handle. That angle isn't random at all. It actually allows you to flip the wrench over in super tight spaces to grab the next set of flat edges on a bolt. It's just pure functional design. To maximize utility and save you from lugging around twice as much weight, these wrenches almost always feature 2 different sizes, one on each end. So you might have a 12mm opening on one side and a 13mm on the exact same tool. You always want to perfectly match the precise dimension of the wrench directly to the outer dimensions of the nut or the bolt head you're trying to turn. Section 4. Box ends, 6 versus 12, the geometric showdown. Okay, now let's look at the geometric showdown happening right inside the box end wrench. You generally have 2 main options here, a 6-point design or a 12-point design. The 6-point perfectly mirrors a standard bolt, providing a much stronger grip that won't round off those stubborn fasteners. The 12-point, however, sacrifices a tiny bit of that raw grip for a massive, massive increase in versatility. And here's exactly why that versatility matters so much. If you're using a 6-point box end wrench, because of the basic geometry of a hexagon, you are required to swing the handle of that wrench a full 60 degrees of rotation just to unseat it and hit its next available position on the bolt. But the 12-point wrench cleverly halves that requirement. It gives you the huge and often absolutely necessary advantage of moving the fastener in tiny little 30-degree increments. Because think about it, when you're stuck deep inside a tightly packed engine bay and your handle can literally only move an inch before hitting the radiator, that 30-degree engagement is the difference between getting the job done and just giving up. Section 5. The anatomy of sockets, deep dives, and heavy impacts. Now, sockets are essentially an entire ecosystem purpose-built for different scenarios. They let you reach perfectly into deep recesses where a normal wrench could never ever fit. You can pop on swivel attachments for accessing bolts at totally bizarre angles. You've also got deep sockets, specifically designed for nuts where a long section of thread is left exposed. And just like our box wrenches, sockets come in 4, 6, 8, and 12-point designs. A crucial takeaway here is that the 4 and 6-point sockets are inherently stronger than the others. Why? Simply because they contain a thicker, heavier mass of solid metal. But as we step up from your standard hand ratchets to those heavy-duty pneumatic impact guns, it brings up a really fascinating visual question. If you look at a professional mechanic setup, almost all their standard hand tools have this beautiful, shiny chrome finish. So why aren't their impact sockets shiny and chrome? Well, the surprising answer lies in the intense physical violence these tools have to endure. Impact sockets feature drastically thicker walls and far heavier construction to absorb the brutal shock of a pneumatic gun hammering away at a seized bolt. Under that kind of extreme rapid fire vibration, a shiny hard chrome finish would actually shatter. It would crack and flake right off into the air like shards of glass, making it a major safety hazard for the mechanic's eyes and hands. So they're intentionally left with a matte, unplated finish. Form always dictates function. Section 6, Rules of the Wrench. Putting it all together safely. First off, let's just appreciate the combination wrench. This tool perfectly marries the concepts we talked about earlier. It features an open end on one side and a box end on the other, both in the exact same size. Now, the pro mechanic technique here is to use the secure, slip-free box end to break loose a stubborn, frozen nut. Once it's loosened up and that heavy resistance is gone, you quickly flip the tool over and use the open end, which is way faster to slide on and off, to spin the nut the rest of the way out. It is quite literally maximum efficiency in your hand. And here's a safety principle you absolutely must remember when using an adjustable wrench. The golden rule is this: adjustable wrenches have one solid fixed jaw and one movable jaw. You've always got to pull so the rotational pressure is forced against the solid fixed jaw. If you pull against the movable one, the mechanism flexes, the wrench slips, and you'll probably smash your knuckles into the nearest hard piece of metal. Trust me, you don't want that. When you break it down like this, it completely changes how you view something as simple as a wrench or a socket. Understanding how specific jaw angles, 30-degree geometric increments, and the metallurgical differences between chrome and impact-rated steel drastically alter performance, it really leaves you wondering just how much quiet, brilliant engineering goes into the simplest object sitting right there in your garage, patiently waiting for the right job. Thanks for joining me on this explainer, and I hope you look at your toolbox in a whole new light.